Well, we have another question here. The question says, question 4 says, the sketch below shows the graphs of f of x and g of x. Graph f has intersects at A and B, and a turning point at C. The straight line G passing through A and C cuts the y-axis at E. Now, in the previous videos, we did questions 4.1 all the way through question 4.4 in one video. Now we're going to do question 4.5. Questions over here. The question says, determine the equation of determine the value of k if h of x equal to 2x plus k is a tangent to the graph of f. Now I'm gonna add this one. So we're doing now question 4.5. Okay, the question says that h of x is equal to 2x plus k, and then this one is tangent to f. Now I want to move my board over here. Okay, and then I think I need to redraw the same graphs over here. Okay, we're going to do I'm gonna draw the question here. So we're doing question 4.5. So it is given that h of x equals to 2x plus k, and then this graph is tangent to f. Now, so we need to find here the value of k. All right. What do we know about tangent of the line? We know that tangent of the line touches the graph at exactly 1 point, and also we know that the gradient of the tangent is equal to the derivative of the function. So I'm gonna say m of the tangent line like that. Okay, let's write the formula. Write the formula in red. M, the gradient of the tangent line, is equal to the derivative of the function. Okay, if you check your notes, you see this is the formula. Now we will going to first find the derivative of f of x. F of x is given by negative 2x squared minus 2x plus 3. Okay, so the derivative of f prime of x will be negative 4x minus 2. Now we're going to set this equal to excuse me equal to excuse me, f of x. I didn't write it. Okay, f of x not that exactly. F of x is equal to negative x squared, okay, minus 2x plus 3. So the derivative of f of x, f prime of x, will then become negative 2x minus 2. Now we know that the gradient is just the coefficient of the quotient of the straight line is the coefficient of the x. So this is the gradient. This is empty. So therefore, we're gonna say therefore 2 equal to negative 2x minus 2. So if I move the 2x over, and then if I move the 2x over here and then move the 2 over there, so we will have like 2x equal to negative 2 minus 2, and then 2x is equal to negative 4, and then therefore we divide both sides by 2, by 2, and then we get x equal to negative 2. Now we found the value of x. So meaning it is the tangent is when x is equal to negative 2. So now we will find f of negative 2 then, okay, which because f of x, okay, let me write it this way, because initially f of x was equal to negative x squared minus 2x plus 3. We need to find then which point exactly, because we find the x coordinate, we need to find the y coordinate to identify the points, okay, on which the tangent lies. Okay, so we're going to do f of minus 2. Over here, we're going to substitute x by negative 2, and then so I'm going to use a calculator for that. Just we're going to substitute so like negative. Let's just move it a little bit closer to here, and then we have like negative. We open brackets minus 2 to the power of 2. Okay, and then minus 2 open brackets negative 2. We sub in the value of x plus 3. So over here, we sub in the values of x, which is negative 2, negative 2. Now, when we hit equal, and this is equal to 3, so that means f of minus 2 equal to negative 3. This simply means when x is equal to negative 2 or positive 3. When x is equal to negative 2, y equal to 3. So this is the points where the tangent line lies, the points on f. So this is the point on f where the tangent line lies. My guess is somewhere there maybe. Okay, so the point, okay, x is somewhere there because it's negative, and then 3 is there, and then the tangent line will touch the graph only one place, something like this. Okay. Now that we got the points, we can now find the value of k. So we will say, since h of k since h of x is equal to 2x plus k, we can substitute, because it's the very same point that lies on the graph of f, lies also on the tangent line. We can substitute the values of k of h of x, which is y, which is this value 3, and then x value is negative 2. So we have like 3 equal to 2x plus k. We sub in the values of y and x. So this is like 3 equal to negative 4 plus k. And if we move the negative 4 over, we have like 3 plus 4, and then therefore k is equal to 7. So this is the answer. The value of k. Now, the following question says, I'm gonna move my board over here. Question 4.5, 4.6 now. Okay. Question 4.6 says, determine the equation of G minus 1, the inverse of G in the form y equals to. So now, I move my board. Okay, so we have like a 4.6. So we are looking for the equation of G minus 1. Okay, the inverse of the function. So we do know that g of x was given by if I look at the question there, g of x is given by mx plus q. Okay, it's over here. G of x is given by mx plus q. In the previous video, in the previous question, we did work out this equation of G, because we had the point A, and then we used the point A and the point E to work out G. We can just go back and see what was the equation over here. We did find that this is the equation, okay? Y equal to 2x plus 6. Because A is a point -3, 0, and then E was a point 0.06. We use these 2 points to find the equation of the line, and then we got the line 2x plus 6. And then A, just because A and E lies on A, C, and E lies on the same line, same line in this line here, G. Now we can just write Gx equal to 2x plus 6. Okay. Now, if we need to find the inverse, this is what we do. Let's just say that g of x is the same as y, so y equal to 2x plus 6. If we need to find the inverse of a function, we call y x, and then x is called y. Okay, we change the value, so we have like x is equal to 2y plus 6, and then we're going to make y subject of the formula. So this becomes like 2y plus 6 is equal to x. You know, if we can reverse switch the sides. Okay, and then here we don't change the signs. Now we can just move the 6 over. That makes 2y equal to x minus 6, and then we divide by 2. Y will be a half x minus 3. So this is this is the g minus 1. This is g minus 1 of x in the form y equal to. Excuse me. And then we have also question 7. I just want to move my board a little bit here. And then we have like question 4.7. I think I'm just going to post the question here. So here's the question, question 7, that says for which value of x is g of x greater than g minus 1 of x. Right now, so we are looking for the value or values of x. Okay, now g of x, we calculated g of x, we found that it was 2x minus 6, and then g minus 1 of x, we just did it over here. It's a half x minus 3. So this is a half x minus 3, and then they said which value or values will g of x will be greater than or equal to that. Now I prefer to move the x's on the left hand side, so I'm going to take this, I move it over here, and then the -6, I move it over there. Then this will become 2x, okay, minus a half x greater than or equal to -3 plus 6. And now this will make what? If you do 2x minus a half x, you will get 3 over 2x greater or equal to -3 plus 6 is just 3. In case you're struggling with fractions, this is what I did over here. 2x minus a half x. First, I made this 2. I know that this 2 has a denominator of 1. Now, I want the denominator to be common. So what I'm going to do is that I times here by 2, times here by 2, I times there also by 2. Whatever you do at the numerator, you do at the denominator. Whatever you do at the denominator, you also do at the numerator to keep your fraction the same, okay, to keep it even. Then this will become then 4x over 2 minus a half x. Now that the denominator are common, you can just work out the numerator, okay? You can just say, okay, therefore, this is just equal to 1x, this is 1x. You just do 4x minus 1x, which is equal to 3x. So I'm gonna write 3 over 2x there. So this is how I got the 3 over 2x greater than or equal to 3. Then, if I need to find x, I can just times the right hand side by the inverse of this. Okay, so I wanna do x will be greater than or equal to 3 times by 2 over 3, the inverse of that, and then this means that x must be greater than, so we can cross this out, x must be greater than or equal to, greater than or equal to 2. So those are all the values that are greater than, so it's like, if the number line is this, 2 is somewhere there, so it must be all these values from 2 inclusive all the way to the infinite. So this is the answer. Thank you. Oops, hold on, there was a mistake here. Over here, we have like, it's positive 6x. Let's double check. Yes, the g of x was positive 6x, so 2x plus. Oh la la, we're about to make a mistake. So now this will be, so this will be changed, this will be negative, negative 6 then. And then over here, it wouldn't be 3, but negative 9. So, and then, so this is 9. So if we simplify negative 9, then if we simplify by 3 as we did here, we're left with negative 3. So negative 3 times 2 is equal to negative 6. So this is negative 6. X must be greater than negative 6. So negative 6 over here. Negative 6. Now we're done. Thank you.